and thank you for joining us today for Surge Protection: When, Where, Why, and How. I'm Sue, Midnight Solar's North American Sales Manager, and we are here today also with Ryan, our Applications Engineer, and he is going to talk to you guys today about our surge protection devices and give you some examples of exactly where those are used, why you might want to use them, and a few more tips on other prevention of surges entering your system. So with that, I'll let him go ahead and get started.
Thank you, Sue. We're going to give it just 1 or 2 more minutes. We've still got a lot of attendees rolling in, and then we'll jump right into this.
Also, if you do have any questions during the webinar, feel free to either put them in the question pane or raise your hand, and we will address those as we go along.
All right, so we're going to talk about surge protection: when, where, why, how, what to use. Some of the common mistakes, common things that are overlooked. I shouldn't necessarily say mistakes, but pieces and parts of the architecture that are overlooked. And we're going to jump right in there. So let's see if we can get the slide deck going here. So who we are. We do this slide on every presentation, but we've been in this forever, back from Trace through to Outback, now Midnight. Very innovative, one of the largest combiner manufacturers in North America. Probably around 100,000 classic charge controllers out the door. And that's where we're located, right inside the good old United States of America. We manufacture everything from Midnight Solar right there, and built right in Washington. We have our own circuit board machines, et cetera, et cetera. So all of our employees are here in the U.S. Customer service agents are all over the U.S. So you might be getting somebody in Florida, somebody in Maine, somebody in California. A lot of experience and a lot of knowledge. So what we're going to talk about, we're going to talk about some different applications. We're going to talk about mobile, not just, stationary residential type things. We're going to talk about the different types of surges, lightning strikes, grid, solar flares, EMPs. EMPs are a hot topic right now with everything going on between Iran and Ukraine and Russia, and just a lot of concern over that as well. But even with the weather, solar flares, lightning, a lot of things to think about here. So before we jump into our SPD, I want to take some time because we had a customer call us the other day that got burnt by this. There is a Chinese knockoff of our SPD for sale on eBay and Amazon. Rather misleading. It does not actually call it a Midnight Solar. However, it calls it a replacement for a Midnight Solar. The box will say it's Midnight Solar. It looks fairly different. You'll see green mauves. You'll see a yellow ground wire instead of a green ground wire. And then the other giveaway is the black heat shrink. We give you white heat shrink so you can relabel one of the wires for neutral, as you'll see later. You'll also notice it's hard to see in this picture, and most of the pictures on eBay and stuff are done on purpose that way. But there is no Midnight Solar logo on the SPD. So why should you steer clear of this one? Many reasons. So one is the plastics are much thinner and probably not the right material. I haven't actually tried to light one on fire yet, but they are definitely much thinner, about half the thickness of the one that we use. And that's important because under certain conditions, either a direct lightning strike, those MOVs inside explode, and the plastic contains that. Sometimes we see the plastic crack, but that is what that's there for. Those SPDs will explode under a direct strike, and that contains it. So if you're using inferior plastics and the MOVs explode, then you're going to have molten stuff all over the house. The other reason is if you're in a scenario where the voltage goes slightly high. So let's say you've got a SPD 300 on your utility grid, and the grid goes to 600 volts for some reason. That SPD will conduct, and it will conduct a certain amount of power, and it'll get extremely hot. There's a fuse inside there on ours that opens and makes that safe before it actually catches on fire. It's a very edge case, but every surge arrestor has this edge case, and they all have a protection for that. They copied our fuse, but they did not use the right material and they did not solder it down correctly. So that one would actually catch on fire in that case. Probably the biggest one is it is not UL listed. So anybody that's ever been through anything with any kind of a claim, fire claim, that, in this case, knows that the first thing any insurance company inspector is going to look at is every piece of product on the job. And if there's a product that isn't listed, that's something they're going to point at and generally blame the homeowner slash installer. Makes it a little bit harder. And it's not conformal coded. I'm trying to figure out if there's anything else really sticks out, but those are the reasons. Just make sure you're purchasing from an authorized Midnight dealer. If you have any questions, reach out to myself, Sue, Charlotte. Any of us can help you. Any of the support team can help you. If you're on Amazon, usually the giveaway, like I said, is the yellow wire and the green MOVs, but look for one of our authorized sellers. Look for our brand on the page. So far in the States, I have not seen them actually using all of our pictures and branding. I have seen that in Europe on eBay over there. One of the sellers did actually use all of our pictures and everything. So you thought you were buying ours, then you'd get this one. So, and if you've had an experience with this, definitely reach out to us. We want to help you make it right because we do feel these are not safe for you and we don't want you stuck with something that isn't safe. All right, down off my soapbox on fake SPDs. Use a reputable product, use a listed product, Midnight, Cytel, Square D, etc. Just, don't buy an unlisted product. So we're going to talk about some applications. This is Sue's RV that she likes to go boondocking with. Just kidding. There's some serious solar on this bad boy. A lot of people think that an SPD requires a good ground to work. And the actual theory behind a surge arrestor is not so much getting the power into the ground as it is keeping everybody at the same playing field. And we'll show a little example of that later. But in this RV, for example, you've got 12 volts and you've got 12 volt appliances, and you probably got 120 volts of that much solar, right, in an inverter. So if that RV, for example, came in contact with 5,000 volts, if everything in the RV went to 5,000 volts, then it'd be 0 volts across anything for potential. And that's what your SPD is trying to do in a mobile application, right? Like if you take a bad surge, we're trying to keep everything at the same. So your L1, your neutral, your ground are all at the same potential. Now those all three could be 2,000 or 3,000 volts compared to the pedestal you're plugged into during a strike. But as long as all three are at that potential, there's no delta between them, no voltage difference between them. There'd be no arcing over, there'd be no damage, and you would save your product. We have seen many RVs with lightning damage. RV parks notoriously don't have a lot of lightning protection. And you have long cords laying out, you got wires buried everywhere in the RV park, great antennas. Lightning strikes a tree a couple hundred feet away, 1,000 feet away, that's all sucked up by that, and a lot of damage can happen. So not just a stationary product, definitely can be used in mobile. Definitely look at your 12 volt system and your 120 volt or 12240 if you have that in the RV. Protect your neutral. That's another big one. We'll talk about that later in the residential side. But don't forget that neutral, because that is a channel into everything. Remember, like I said, if you've got an inverter and it's got a black wire, white wire, and a green wire, if the black wire, the white wire, and the green wire are all at the same voltage, there's no damage because there's no potential. But if you leave that white wire alone and you've got 2,000 or 3,000 volts or more, now that white wire is down at 0 and you have potential and you'll get arc over. So yeah, keep that in mind. If you're running lead acid batteries, the 12 volt system is probably a little bit more stable. Lead acid batteries make a great surge suppression device all in themselves. But if you're running lithium batteries with BMS, definitely put a 115 on the 12 volt battery to protect the system and the battery itself. BMSs cost money, batteries cost money. We want to protect those. That's another common failure we see in the industry now, is with the transition to lithium being very prevalent. We're seeing a lot of BMS failures during lightning storms, and that is because, we're not necessarily thinking to protect those batteries because we always had that mentality that batteries are a great surge arrestor. So we're going to talk a little bit about surges and what you can do about those, what ones a typical SPD will cover, what you might need to do if you're doing something for other surges. So you have several types. Probably the most common is surges coming in from the utility grid, be it a lightning strike downstream somewhere that's on the line or substation issue. One of my ones I always reference is here, up here in Maine where we live. There's a 3-phase line going through town, and one of the phases went to a multiplier of 10 somehow. They claim a squirrel got in something in the substation. So if you were unlucky enough to be on phase B, I believe it was, or phase 2, you went to 2400 volts instead of 240 volts in your house. And that was kind of bad. Things didn't like that. If you had a good whole house surge arrestor like a Square D or a Midnight or something, they seemed to be fine. The ones that had no protection, they had 7 or 8 structure fires on that line because of that. So that's a common one, grid-based surges. So whether you're solar or not, we absolutely recommend whole house surge protection, and then also any sub panels we'll talk about later. Lightning is another one. A lot of people think that, hey, if I don't take a direct strike, it's not a problem. But you can get a lot of induced voltage by a nearby strike. Lightning can strike quite a ways away, actually, and you'll get some pretty incredible induced voltage. I've always wanted to run an experiment where I take like 100 feet of 12-2 Romex and twist all 3 wires together on one end and put, like an oscilloscope or something on the other end so I can catch it quick enough during a lightning storm, but I haven't quite been brave enough. It would be really interesting to see what there is there, but there is a lot of induced voltage in wire. It makes a great antenna. Direct strikes are a little tougher, but with the right equipment in the right places, you can be pretty lucky most of the time. I'm not going to sit here and tell you that my product will absolutely 100% stop you from damage during a direct lightning strike, but I'm going to tell you that if you do everything right, you have a high probability of surviving that lightning strike with very minimal to no damage. And we'll talk a little bit more about that as we go on, but that is something to be very aware of. Direct lightning strikes are no joke. I had a customer that unfortunately lost his whole complete system due to a direct lightning strike, and it turns out there was no SPDs on the AC side of the inverters because it was off grid, and the assumption was off grid, the wires don't go out to the utility. There was nothing to worry about. But again, that whole house is an antenna, and that went into the inverters and just fried everything. Another common one, uncommon one, I should say, that we talk about once in a while is solar flares or CMEs or coronal mass ejections. Basically, it's a big electrical pulse that comes out of the sun. It spews a bunch of stuff out into the atmosphere, and if it's headed in the right direction, the Earth is facing the right way, we get plastered by it. There's been some pretty amazing documented cases of that before, way back in the day of the telegraph, all the things catching on fire from that, and that's fairly rare, but it's extremely possible. And all the SPDs that are quality on the market, like ours or Cytel or whatever, they will all protect you from that. So it is a fairly slow-moving thing relative to like an EMP, and we can catch that plenty fast. The one that really is tricky is the EMP, or electromagnetic pulse. So those that don't know what an EMP is, it's basically a electrical blast from a nuclear detonation. The theory is that somebody that doesn't like us would light off a nuclear bomb in the atmosphere above us, and that would slam the earth with an electrical pulse that would fry everything. And I'm not going to go deep into EMPs because that's a whole thing in itself, and there's a ton of stuff out there on EMPs. But essentially, there's like 3 waves to that. There's an initial wave that's centered around the blast that is super fast. And then there's a second and third wave that are slower. And those second and third waves, your surge protection devices like a Midnight or, Cytel are fast enough to catch that. That first wave, however, is so fast that the only savior for that is something called gas discharge tubes. And there are a lot of stuff on the market that claims EMP proof. I'm going to stop short of saying it's snake oil, but I'm going to say that it does not seem to have the size of the components in it that I feel necessary to stop an EMP. I am by no means an EMP expert, but when I'm looking at a circuit board that has a gas discharge tube the size of a grain of rice, and it's supposed to protect my whole system from an EMP blast, I'm skeptical. My general theory is if you're worried about an EMP, put as much stuff as you can on the system, do proper grounding, take all of the precautions, and then have spare equipment in a Faraday gauge. And speaking of best practices, so there's a lot that goes to installing a system for to protect it, not just surge arresters, right? You just throw the system in, throw surge arresters on it, and you're done. If you're doing long wire runs underground, sharp bends coming, where they come out of the ground before they go in the house. Lightning doesn't like to make sharp bends. It's a trick we always use in the radio world. Our feed lines, we'd make a nice sharp, 360-degree bend or 180-degree bend, depending on where you're going, and it will blow out of that cable instead of coming into the building. Proper grounding, run as much stuff in shielded cable, shielded conduit, etc. as you can. Just a lot of common things, and we'll talk about some of the missed things as we get going. So one of the common questions we get is, what SPD do we use? What surge protection device do I use? What voltage? What model? And one of the common misconceptions we get is that people think they need to use the lowest voltage SPD possible because, if I use a 300 on a classic 150, I'm going to damage that classic 150. But keep in mind that every piece of gear that's UL listed has been run through a test we call high pot testing. And that high pot testing basically runs several thousands of volts through the device to make sure that it doesn't bleed to the chassis anywhere. It's a test we all have to do on every piece of equipment. It's like a classic 150 example is high potted to about 2,500 volts, and that is not allowed to bleed through to the chassis anywhere. And if it does, then it fails. So with that in mind, and remembering back that the SPD's goal is to keep everybody at the same potential, when that happens and that lightning strike happens and there's, say, 2,000 volts coming into that PV line, that keeps everybody at 2,000 volts and clamps it down, and there's no differential in the classic and there's no damage. So we don't always want to stay like super close to the model that you think you might need. And an example of that is like if you're doing a PV system, and let's say you're doing two 72 cell modules in series, and you've got 95 volts VOC, and you're like, okay, temperature corrected, I'm still only at 105 volts VOC. 115 is perfect. The problem with that is that if somebody comes in and expands on that in the future, or the array gets changed in the future, they may miss the fact that that SPD is a 115 and not a 300. So let's say you've got a classic 200 in there because that's what you had in the truck, or a classic 250 even is a better example. That's what you had in the truck. You put two 72 cell modules in series and you did 6 strings. And then 6 months later, 2 years later, whatever the homeowner calls us, is I'd like to expand that system, what they call a different installer. And they look at that system like, hey, great, we got a classic 250, we're only running 100 volts VOC. I'm just going to throw one more module in every string and increase the PV array, and I don't have to touch anything because everything else is sized correctly. And then that SPD is going to be bleeding to, all the time, and you're going to be losing PV production, and eventually the SPD is going to short out and clamp, and you're not going to have any PV production. So that's something to keep in mind. I always recommend sizing the SPDs as I do all the equipment in the system on the device. And what I mean by that is, like, if we're putting in a classic 250, I'm putting in an SPD 300 to stay at the right voltage. I'm putting in the 300 volt breaker to keep at the right voltage. Even if I'm doing 100 volts on the PV array, I'm still going to put 300 volt equipment in so that if I ever expand, I don't get bit by that in the future. The other one that you'll get is, why is there an AC and a DC 300? And long story short is, we used to not have an AC and a DC model. We had a 115, a 300, and a 600. They all lit their LED like this one down here, and they would basically, on an AC system, they would use voltage between the red and the green to light up one LED, black and the green to light up the other LED. Now, if you put that on a PV array, of course, there's no voltage between negative and ground. So we'd only have one LED on in the SPD. And we just got so many calls asking if there's something wrong with their SPD. We went ahead and made the DC model, which all three models now, the 115, the 300 DC, and the 600, use voltage between the red and the black, so you get both LEDs to light up. So that's the difference between the two. You certainly can use an AC on a DC system. There is no difference from a AC or DC standpoint. The only difference would be is if you put an SPD 300 AC on a PV array, you'd only have one LED. That's kind of the gist of it, if you will. And here's just a quick nutshell on how to test these things. If you've got a customer or you're in question yourselves, and you're like, I wonder if this actually works. If you've got a 115, a 300 DC, or a 600, you put the black wire on the negative post and the red wire on the positive post of your car battery, and you should get both LEDs to come on. If it's a 300 AC, green wire on the negative, red and black on the positive, and you'll get both LEDs to come on. You can use a 9-volt battery as well, but everybody has a car battery. Every installer out there has a car battery under the hood of their truck. And when they call me and say, hey, my SPD doesn't have an LED on, if they've already uninstalled it, we run this test. If they haven't uninstalled it, we ask questions. Some of the common reasons an SPD doesn't light up is, one, it's on the AC input of an off-grid system and the generator is not running, so there's no voltage there. The other one is it's in a PV combiner and the ground doesn't run all the way back to the system. It's got its own separate ground rod. So while it's actually protecting, there is no path for the electrical to go back and turn the LED on. Those are your two common reasons not to get LEDs, but the most common is the one on the AC input. We get calls a lot about one of your pre-wired systems and one of the SPDs isn't lighting up. And it's like, hey, start your generator. Oh, there, lights are on. And that's it's still protecting. Like if there was a lightning strike, it's still protecting that inverter. It's just not turning the LEDs on. So UL requires us to have a visual indication of failure. So we chose to go with LEDs that are on when the device is good. If the LEDs are out, then that means it's either not got power or it's used up and it's opened its fuses internally. So here's a little bit about what we're going to talk about where do we put these. This is kind of the biggie, right? This is where we spend our time, and this is the meat and potatoes of it. So we're going to go through these one by one and talk about where we're going to put these SPDs and why we'd put them there. So the first one, which is, like I said, a no-brainer, is your service entrance panel coming in from the utility if you have a utility. As close to the main breaker as possible. You'll notice in both images we're tapped into the top right near the main breaker. You can do a dedicated breaker if you have the space, 20, 30 amp AC 2-pole breaker. Or if you don't, you could grab a circuit near the top, like a well pump or something like that, and you can splice the wires using the appropriate, splices, whether it be wire nuts, Wago connectors, Polaris connectors, whatever you feel comfortable with. As long as it's listed for that job, you're good to go. Some breakers are listed for double wires under the breaker. You have to check that out. So in this example over here on the right, if the breaker was listed for 2 wires, you could put the 2 reds under one and the 2 blacks under the other instead of splicing them. So that's a couple ways you do it, but always start with the main panel. Most importantly, that is the one you put in. If that's the only one you can afford, that is where you're going to get, I'm going to say 75, 80% of your damage, maybe more, is always going to come in through that utility. Now, subpanels. This is where it gets interesting. So people think, hey, I've got one in my main panel, but I've got a barn out there that's 300 feet away, and I got a great big woodworking shop, or I've got it in a studio apartment in it. But it's protected because I've got one at the utility grid panel 300 feet away. My general rule of thumb is if you have a wire run longer than 50 feet, put something at the other end of that wire. So in this example of the barn being, say, 300 feet away, now all of a sudden, if there's a lightning strike nearby, that's induced voltage, it's going to head out to that barn and cause a lot of damage. So that is what we call a sub panel in the barn. And 99% of the time, the ground and the neutral are separated in that subpanel. And we need to protect the neutral because the neutral is now basically, it's bonded back at the main panel, but 300 feet away during a lightning strike, it's technically not bonded anymore because the resistance in that wire is going to let that voltage go crazy. Think about taking, say, 1,000 feet of 12-2 wire and trying to run 10,000 volts across it. If you're running 10,000 volts at, say, 5,000 amps, by the time you get to the other end, you're going to have like a tenth of that voltage. Well, you're going to have burnt up wire, but that's a different story. If the wire would handle the voltage drop would be incredibly insane. And this is a very common failure point that we see, is the neutral doesn't get protected in those subpanels. So in this case, you use a couple SPDs, use the white heat shrink that we include on the blacks and put them under the neutral, the greens to the ground, and then the two reds to the two legs of your subpanel if it's 240. If it's 120, then you only use one SPD, white to neutral, green to ground, and your red wire to your hot leg in your subpanel. But make sure we're protecting that subpanel. So the other one we get a lot is PV to MPPTs, and this is becoming more and more of a hot topic with all the all-in-ones, and we'll go a little deeper into that in a minute. But where do you put it, right? You've got 500-foot wire run coming in on a 600-volt PV array. Do you put it at the PV array? Do you put it at the inverter? And generally, my rule of thumb is if you're only going to do one, you put it at the inverter. The inverter is your most valuable item. Put it there. And if you can put a second one at the PV array, that's great. That's just extra protection. But again, if that's out there at the PV array and you've got a 500 or 600-foot wire run and lightning strikes that wire, the resistance in that wire, you're going to have thousands of volts in here at your electronics. So definitely want to put it at your electronics first, and then if you can afford the second one, put it at your PV array. And this is just a couple of use cases, couple examples. Our PV combiner boxes, a lot of the bus bars have a second hole, so you can crimp a ring terminal on the wire and land it on the bus bar. If it's a combiner and you're not using all the strings, you can throw an extra breaker in there. We'll show a picture of that, I think, in a little bit. The Rose E panel, for example, has pickoffs that you install to install your SPDs for AC and AC out, PV and battery if you need to. Just, get that connected as close to the electronics as you can, and keep the wires on the SPD as short as you can. Nice sweeping radiuses, no sharp bends, etc., etc. And we do have a question about the subpanel. Have we thought about creating another version with 3 legs? And that's a great question. It's certainly been tossed around a lot. I don't believe it's on the roadmap right at the moment, but it is definitely something we're looking at. So here's a better picture of what I was talking about. Sue got me a better picture for this one for sure. So this bus bar has these holes in it where you can crimp the ring terminal on the SPD and land it right on the bus bar. Now, that being said, let's say you was only using 4 strings on each side instead of 5. You could put it under a fuse holder and put a 30-amp fuse in there. That would be just as acceptable as well. The only downside to putting it in fuses or breakers for me is, let's say we come out to work on this for some reason and we lose a fuse, or some reason we break a fuse or blow a fuse. It's awful easy to rob the one out of the lightning protection because it's not actually affecting customer production. So that's the only downside. It's easy to rob. It's easy to overlook, if you will. So keep that in mind. But most all of our combiners have some provision for installing those. And here's the one that I was talking about. This is a better shot of the Rose E panel. These little pickoffs snap in and give you a place to connect your SPDs, as you see there. Something that I want to point out is AC ins and AC outs. Any input or any connection to an inverter, let's say. Again, I've had a customer who had a off-grid system smacked by lightning, and he's like, well, the only thing going to the input's a generator, and it's 50 feet away. I figured it was safe, and that came into the input. So if there's any wire hooked to it, I highly suggest putting a surge arrestor on there if you're in a lightning prone area. It's one of those areas where it's a little bit of money up front, but when things go wrong, it's a lot of money on the backside and or insurance claims or however you handle that. So it's pretty cheap insurance to protect all of those inputs and outputs of expensive equipment. Here's an example of one being installed in a 120 volt E panel. So if you've got an Outback FX, a Magnum MS, a Samlex, a Little Rosie, you have 120 volts, so you don't have the second leg. So you use a single SPD 300 AC. Use the black on the AC in and the red on the AC out. You can use either color, either place. They're interchangeable. But you protect the AC in and the AC out with a singular SPD. So that's a bonus. You get to use one. And I got a question about the Rosie E panel and a second for the neutral. Generally speaking, no, because the Rosie E panel is either going to have your neutral to ground bond in it if you're off grid, or it's going to be so close to the main panel that the bond is sufficient to cover the neutral in the Rosie E panel. So the Rosie E panels ship with a neutral to ground bond internally, and if you're using them in a grid connected environment, you remove that bond. So I would say, generally speaking, no. If you've got a use case where the Rosie is a couple 100 feet away from the main panel and the bond is in the main panel, then you might want to think about it, yes. Yep. And batteries, we talked about that a little bit, but historically we've always said that, hey, a lead acid battery is a great surge arrestor. I've seen lightning strikes where the batteries are actually physically blown apart, but it didn't damage, a lot of the stuff because the battery absorbed it. But now with the lithium batteries and the what we call a BMS, a battery management system, protecting that is pretty important because those things aren't cheap. You're either going to have to replace the battery, or if you're lucky, you can buy a replacement BMS and replace that. Either way, you're into some cost and some labor, and it's not going to be a ton of fun. So highly, highly, highly recommend an SPD 115 on the battery side of the system. You can put that, usually you can put it right in the Rosie E panel as shown here. If you have a better place to put it, you're more than welcome to do that. Battery cable's usually pretty short, so we're not terribly worried where it goes as long as it's in that system somewhere. So just you kind of pick a place that's convenient, right? Like if you're using an E panel, there's usually a very easy place to wire it up in the E panel. If you're using some other product, then you may have to be a little more creative or crimp ring terminals on, landed on some studs. Like for example, in a Solarc all-in-one, you could crimp a couple ring terminals on there and throw it on the battery terminals right in the Solarc if you wanted to. Or the Midnight all-in-one, you could do the same thing. A lot of different ways to skin that cat, but just go ahead and make sure you get that in there. Three-phase is another one we get questions on, not quite as often, but we do get questions quite a bit on three-phase. You can do it with either 2 or 3 as shown. And this is going to be recorded. You guys can get a copy of this so you don't have to take pictures or whatever. But if you're doing 2 on three-phase, then you do one leg of 1 to phase 1, one leg of that 1 to phase 2. The second SPD, you'll go to phase 2, and then the second leg of that will go to phase 3. Or if it's a real high value item and you want to just add a little extra protection, you go ahead and use 3. When you're using 3, though, make sure that you actually put the red and the black lead to separate phases, or you will not get an LED. So, red of 1, black to the second phase, and so on. Just go ahead and add that, like that. If you're doing a common one that I've seen is like the big Berge 3-phase wind turbines. People like to put 3 on because the Berge's fairly expensive and getting protection makes sense. So they will cover 3-phase up to 480 volts AC. You can use the SPD 600 for 483 phase AC, or the 300 AC for 208 3-phase. So if you're doing a 3 stack of Rosies for 208 3-phase, go ahead and use 3 of them. So we talked about long wire runs, and here's my image. I probably should have had it up further. This is something I've always wanted to try, but I've never had the braveness to actually sit out there during a lightning storm with my meters and try this. But a long wire, if you could picture this wire with all 3 conductors twisted together, you would think, okay, it's always going to be 0 volts at the other end. But because of the resistance and voltage drop in the wire, during a nearby lightning strike, it can be thousands of volts induced into that wire, and the resistance allows there to be a pretty high potential on the other end. So that's just something to keep aware of. You know, the more lightning prone the area you're in, the shorter that distance may be. If you're in an area where lightning is extremely rare, then okay, you protect from the utility. Maybe you put them on the SPD, on the PV. You know, you have to make that call, right? Like, what is the protection worth to you? Um, it just depends on the area you're in and how much money you've got tied up in equipment. So here's another favorite question I get a lot is my inverter, my charge controller, my whatever has built-in surge protection. Why do I need SPDs? And this was I want to say this was driven by the all-in-ones for a lot of part because they were trying to be super competitive. And when you can say you have your lightning protection built in, it saves the customer more equipment. And to that point, every device manufactured has some amount of MOVs built into it. Generally, they're not quite as robust as like a lot of the other SPDs. Sometimes they are. Sometimes they're repairable. Sometimes they're not. I'm not going to name brands, but some of the all-in-ones, if you smoke the MOVs in it during a surge, you're going to be swapping the inverter out. You can be sending it in and getting another one sent back. Some you can swap MOVs, but it may be a fair amount of work. You know, you're tearing the inverter apart. So there's different reasons to add surge protection to an inverter that already says it has it, and it just depends on what the device is. But I always recommend external surge protection because it's going to take the brunt of the work and save the electronics. And again, even if you've got a midnight all-in-one and you can replace the MOV board in it, you still have to tear the inverter apart to do that. It's not, it's not hard, but it's not super easy. Whereas a surge arrestor, you can unhook the 3 wires, spin the wing nut off in it, put the new one in, hook the 3 wires back up, and you're back in business. It's just it's another level of protection. It's another layer before you get to that device. And I'm also kind of a school of thought: why let it even get to the device, even if the device has quality surge protection built in it? So we always recommend it, even if the devices say they have it. But you know, there you go. That's my reasoning for that. Um, so there's a question about the knockoffs. I think maybe they came in later. Um, yes, there are knockoffs on Amazon and eBay. I have a slide quite a ways back here. I can get back to maybe show you the picture. While I'm getting there, the real key is to look for, official midnight resellers. If you've got any doubt, go to our website, look at our where to buy. They'll all be listed there. Pick up the phone, call Sue, myself, Charlotte. We can tell you where to purchase one of these that you'll know what you're getting. But if you're looking at them on eBay or Amazon and they have the green mauves, they don't have the midnight logo, they have a yellow wire, or they have black heat shrink, they are a fake. They are not going to be ours, and they are going to most likely be dangerous because this is the only one I've seen, and I have done quite a bit of analyzing on this. I do plan to do some destructive testing, but I'm doing all the non-destructive stuff first. But definitely, if you see it and it doesn't smell right or feel right, pick up the phone and give us a call. We are actively working to protect our brand on Amazon. eBay is a little tougher, although eBay is really good about making the seller remove all references to Midnight Solar, but you can only hit 5 eBay sellers a day, and there seems to be 5,000 of them on eBay. I think it's all the same person with multiple accounts. Um, so yeah, just keep that in mind. There are definitely fakes out there, and they are definitely not safe. I do not recommend using anything that is not UL listed if you can help it. So other points of entry. This is another one that I kind of want to hit on a little bit before I let you guys go. And it's communications, it's stuff like that, long runs of that. We see also often people run Ethernet out to a power shed to get internet so they can connect these devices to the internet. And that is a amazing source of input right into this hardware that will fry virtually everything most of the time. You start coming in on the communications and you're on the low voltage side and it just goes through everything. So if you're doing Ethernet like that and you want to run Ethernet a long ways, there's you can buy them on Amazon. They're relatively cheap. They are Ethernet to fiber optic converters. So you can buy a pair of these for like $60, and then you buy a fiber optic cable to go between them, and now you've optically isolated the equipment. So let's say you're going out to that power shed, you could run the fiber the whole way, or you could run a short piece of fiber just optically isolate it, and now the electricity can't follow that Ethernet out to that shed. There are surge arresters for Ethernet cables. Beware that if you're doing something like a Snyder inverter or a Midnight Rosie that has CAN bus, they frequently put voltage on the CAN bus. So if you use like an Ethernet surge arrestor, a lot of times that will cause some pretty bad problems because it's trying to short out that voltage on the CAN bus. So you've got to be aware of the systems. If you're intent on running like a MNGP2 for a Rosie 200 feet into the house, run shielded Cat5 cable, pull the shield and the drain out of one end and solder a wire to it and land it in the ground lug in the box. So inside that Rosie E panel, ground the shield and the drain right to that ground lug, leave the other end floating. And now you've protected that wire. You should absorb 90% of that and minimize your risk. So those are some of the common places I see that get overlooked is communications, internet, um, displays, remote displays, all of those low voltage cables we tend to, I think, just, overlook them because it's not something that we think of as like dangerous or problematic. But in most cases, they are a perfect tunnel right into the hardware that can do, drastic damage. So keep that in mind. If you've got any questions on that, like if you're doing a system and you're like, hey, I pretty well thought of all of this, but what about this? Pick up the phone and give me a call. Give Jim Parrish a call. Either one of us can help you quite a bit with that. We've both got a lot of experience with lightning, surges, induced lightning. But that's kind of the key is just don't take anything for granted. If you think you've got any questions, send us a wiring diagram of the one line diagram of the system with some wire lengths on it. We'll help you, place those SPDs appropriately. But that's kind of it. That's some of my common failures that I've seen. That's some of the common entry points that we've seen missed. I always feel bad when a customer calls me and they've got thousands of dollars of damaged equipment. Um, but 99% of the time, we find a point of entry that wasn't protected. Generally speaking, we have really good success with saving equipment. I mean, one of my favorite stories is I got a call from a lady one day who said, I've out here on my lawn and after a bad storm and I found a piece of clear plastic that has your name on it. Says Midnight Solar on it. And I found a phone number and I called you guys. Do you know what this is? I'm like, well, it's probably one of our surge arresters. I said, do you have solar on your house? And she goes, I sure do. And I'm like, do you have a big gray box somewhere? She goes, yeah, right up there on the side of my. And then she got real quiet and stopped talking. She goes, there's a black hole in the side of it. She had taken a lightning strike and it actually blew the SPD out of the Solar Boss combiner. When the installer got out there and replaced the combiner, the Fronius inverter still worked. So there's a lot of stories like that. One of our distributors in Ohio, I was out there visiting for a dealer conference, and they've got 6 or 7 SPDs that are just black as black as black inside, all charred. And they're all lightning strikes. And every one of those has a story behind it where the equipment still worked. Now, like I said, I don't guarantee anything during a direct lightning strike, but if you take all the proper precautions, you can set yourself up for some pretty good success and some pretty good dependability. So